Hi, ready? Okay. Good afternoon. My name is Juan Rojas. I'm doing a Master of Science in Aerospace Engineering, but my focus area is structures. I hope you guys like what I'm going to teach you today. So let me talk about today about the stress-strain relationship. But before we start talking about that directly, let me introduce first the concept of stress. Basically, the stress is equal to the force divided by the area. Another way to understand the concept of stress is like this. If, for example, I have this marker and I apply a force over the board, in this case, the pressure that I have defined up there, the force over the area, will be the force that I'm doing to the board. But the stress would be the reaction force of the force that I'm applying in that case to the board. So that's another way to understand really what the stress is in that case. Now, another important concept that I would like to introduce you today is the concept of strain. The strain basically is the final length minus the initial length divided by the initial length. That's a concept that I will explain more later. Okay, now let's go to the stress versus strain curve. First of all, let's imagine we have a metal. It could be a material, it could be a metal or a composite. And that metal, we have a small specimen of that material. It could be a metal or a composite. And let's imagine that we have that specimen of a specified length. It doesn't matter, the length. We're going to put that specimen in a testing machine. We can load that specimen either in tension or compression. Now, let me show you something else. When we are loading the specimen in the testing machine, we are going to get two values. Either when we are loading either in tension or compression. We're going to get the load and also the displacement. And with those two values, we're going to get finally the stress-strain curve that I'm going to show you. Now, let's go back to the concept of stress. The machine is giving us the load that we are applying, in that case, to the specimen. And we're going to divide each load by the area, the cross-sectional area of the specimen that we are testing at that moment. Now, we're getting different values of loads and displacement. And with those two parameters, we're going to make a table. And finally, we're going to make the curve of stress versus strain. That is what I'm going to show you now. What we obtain after getting all the values from the test. What you can observe here is basically the stress-strain curve. So the first part of the curve, which is the straight line, what you can observe there is that the slope, which is E, that you see in the graph, that is a line. That is a straight line. We can consider that as a straight line. When that line is not straight anymore, that's the point where we get yielding. The yielding is the point where the material is not elastic anymore. We enter to a range which is called the plastic range. Okay? Now, the way we measure yielding is to, at this point, at the 2% strain, we make a line that is parallel to this straight line. So what I mean is that we're going to make a line that is parallel. It will have the same slope of the initial straight line, so that we can know the point where the material yields. And that's basically what I wanted to show you today. Thank you very much.